Okay, welcome to part 4 of the ACT practice test, Form 1874 FPRE, which is the 2020-2021 practice test number 1 at the Preparing for the ACT booklet that the ACT puts out for free on their website. So I have a link to that directly at the bottom. Okay, so if you want to go take a look at that, I also posted a link for this directly in the description, which is below this video, and you can use that to access all of the other practice tests that the ACT provides for this year's test. So we're moving on to the fourth section of 10 problems, right? So we're starting off at problems 31, and we'll end at problem number 40. There will be 2 more videos after this that will complete the rest of it. Okay, so the first problem here says that the number 1001 is the product of the prime numbers 7, 11, and 13. Knowing this, what is the prime factorization of 30,030? Okay, so what prime factorization means is let's break down all of the numbers into the smallest prime factors that we can, right? So we can actually look at this list and immediately get rid of 2 of them, right? This one right here, actually 3 of them, right? You can see that 10 is not a prime factor, right? 30 is not a prime factor because I could break that down more. And then I have another 10 that's showing up down here, right? So that would eliminate choice letter C, okay? So the only thing I have left to do is to figure out which of these 2 multiplies to the 30,030. So I'm going to bring up my calculator real quick. And if I just type in, hey, let's bring it up, okay? 2 times 5. 2 times 5. Let's try that again. Times 7 times 11 times 13, right? I only get 1,010, and that's because in choice letter E, I have another number, the 3, and that's the one that I need to get to the prime factorization, right? Another way you could have done that, let's try that again, but with the correct number at the end, right? So you can see that with the 13 at the end, right, I do get 30,030. Another way you might be able to quickly do this if you're not using the elimination strategy is to say 30,030 divided by 1,001 is an increase of times 30. And if you notice, if I take this last one and I eliminate the 7, the 11, and the 13, right, that made 1,001, right, I'm left with 2 times 3 times 5, which multiplies to the extra times 30, that made 30,030, right? So that's the idea with this problem. A couple different strategies, but they both get you to the same spot, and that is choice letter E, okay? All right, problem number 31. This one is actually a 3-part problem, right? So for problems 32 through 34, we'll use this drawing. So let's take a look at the drawing before we get to the actual question, right? So Makia, an intern at the Parks and Recreation Department, is developing a proposal for the new trapezoidal Springdale Park. The figure below shows her scale drawing of the proposed park with 3 side lengths and the radius of the merry-go-round given in inches. And in Makia's scale drawing, 1 inch represents 1.5 feet. Okay, so we're going to take a look at this picture here and then answer 3 different questions about it. Okay, the first one is, what is the area in square inches of the scale drawing of the park? So the first thing I'm noting here is square inches, and that matches the units of my problem, so I don't need to do any unit conversion, right? So we're good there. The second thing I'm going to note is that this one's talking about area, right? And when I'm talking about area, it's a good idea to go check your formula sheet if you don't know the formulas, right? They will give you formulas for most of the geometry calculations that you need. You just have to know to go and look at that, okay? So this shape, this whole park, is a trapezoid, and the area formula, if you look that up, says 1/2 times the height, okay, times the sum of B1 plus B2. And we'll talk about what all that means right now, okay? So in a trapezoid, 2 sides are always parallel, and you can see that this top line here, right, is the only one that could be parallel with something else, and that's, in this case, the bottom line, right? So it's not always top and bottom. The definition of B1 and B2 when we're talking about trapezoids is always the lines that are parallel to each other. So when I plug into this, I'm going to plug into B1 and B2. I'm going to plug in 28 plus 40, okay? The height is always going to be coming out of one of the bases. There will have to be a right angle, and you can see we conveniently have that already, right? So this 16, which is the distance from the bottom to the top at a right angle, represents the height, okay? And that's everything we need, right? So again, I'll go to my calculator, let it do some of the work for us, right? So I'm going to say 28 plus 40 right? I got to do PEMDAS, okay, times 16, okay, times 1/2, which I'm just going to put in as 0.5. And that looks like 544. So that's the total area. I'm going to come back and look at my answers. There's choice letter G, 544 square inches, okay? That's all you have to do for that one. Okay, problem number 33. Same picture, same description. Okay, Makia's proposal includes installing a fence on the perimeter of the park. What is the perimeter in feet? So I'm seeing that. That means I'm probably going to have to use this conversion here of the park. Okay, so the first thing I need to do is find the perimeter in inches because that's all the information I have, right? So I know that I'm going to do 40, which is the bottom side, plus 16, plus 28, plus, oh no, I'm missing a side, right? So we have to do a little work. Really, the work of this problem is figuring out what this side is, and then we'll have to convert it to feet, right? So here's what we're going to do with this problem. This 16 that's right here, okay, can be drawn anywhere in the shape. So if I wanted to, I could cut this shape right here and say it's at a right angle, and it's also 16, right? Wherever I want. Okay, what I'm going to choose to do is move it all the way over here and turn this slanted line into a triangle, okay? And it's going to have a height of 16, okay? I don't know what this piece is, so I'm going to call that unknown. That's what I'm trying to find, right? This unknown side, okay? But I kind of also have an unknown down here. I don't know what this piece is either, okay? Here's where the help comes in. This top piece right here, this blue line, the top base, is 28, which means from here to here on the bottom, since this is now a rectangle, this is also 28, okay? And if the whole bottom is made up of 40 inches, I've used 28 of them. That means that this little piece down here has to be the remaining 12, right? So that's 12 and a 16. And our good friend, the Pythagorean theorem, can come into play here, and we can do 12 squared plus 16 squared is equal to the unknown side squared, okay? And you're welcome to do this calculation, and what you'll find is that this value is 20, okay? Let me help you out a little bit. So, because again, I'm thinking of 60 questions in 60 minutes. I want to try to save as much time as I can. Here is something that shows up on almost every single standardized test that you will ever take whenever they ask you a right triangle question, okay? There's something called a Pythagorean triple. And here's what that means, okay? A very standard right triangle, okay, is one that has legs of 3 and 4, right? And then the hypotenuse is 5. And if you check this, 3 squared is 9, 4 squared is 16, and if I add those together, I get 9 plus 16, that's 25, and that's 5 squared, right? So 3, 4, 5 is what we call a Pythagorean triple, okay? So any list of 3 numbers that works in a right triangle in the Pythagorean theorem, we call a Pythagorean triple. 3, 4, 5 is probably the most used, most famous one on tests, okay? If you notice, the numbers that I ended up with, 12 and 16, 12 is 3 times 4, okay, that makes the 12, right? 16, well, that's 4 times 4, okay, that's the 16. And so what that means, how I can use this, is that the third number has to be something times 4, right? So I'm sorry, 5 times the same 4 that I used on the other ones, right? So if you notice, 3, 4, 5, I multiplied each of these numbers by 4, which means the last one has to be 20. So instead of doing the calculation on the Pythagorean theorem, if you're less comfortable with the algebra stuff, right, you can also just remember that 3, 4, 5 is a Pythagorean theorem and is a Pythagorean triple, and any multiple of 3, 4, and 5 will also work. So for example, times 2 times 2 times 2, I know that 6, 8, and 10 also makes a Pythagorean triple. So if you can start recognizing that the legs are a multiple of 3, a multiple of 4, that means that the last one will have to be a multiple of 5, right? So that's something that you can try out, excuse me, as a test-taking strategy. Okay, in any case, this last side is now 20, and I can add that onto my perimeter, right? All this work that we did, however you chose to do it, either with the Pythagorean theorem or with our triples, right, was used so that I could figure out that this one missing side is 20. Right, so if I add these numbers together, I get 40 and 20 is 60, right? 60 and another 16 is 76. 76 and 28 makes a total of, let's just do this right so I don't mess it up, right? 76 and 28, right? That looks like 104, right? Just wanted to double check and so not do it in my head. All right, so 104 is the number of inches that the perimeter represents. And what they're telling us is that every inch is 1.5 feet. So I'm going to take this number and I'm going to multiply it by 1.5. Right. So again, let's let the calculator do those decimal calculations. Right. So I'm going to pull up my calculator and I'm going to say 104 times 1.5. Okay, and that looks like it's going to be 156. Right. So I'm going to go with choice letter E. 156 is the feet that we'll use. Right. Notice that 104 was an option. That is the number of inches. So there is a distractor element. So be careful when you're reading the problems that you do that. Okay. Last problem dealing with this shape. Okay, and that is the length of the south side of the park is what percent of the length of the north side. Okay. So here's how we're going to do this. We're going to do. If I'm a big fan of is over of and percent over 100 again for any percent problem. Okay, because I'm seeing those words show up in here again. Okay. The quick way to do this problem, by the way, if you're okay with it, if you're comfortable with it, all of these numbers are bigger than 100, right? So I know that if I do the bigger number divided by the smaller number, I'm going to get a number that is over 100%, over 1, right? So if we wanted to do that, we could just kind of take a guess and say 40 is the bigger number divided by 28, which is the smaller number, right? It looks like that's giving me 1.428. And if you notice, there is a 142 and 6/7, which is 0.8, right? So that's the answer, right? If you're unsure about that, though, you can do your is over of percent over 100. They're actually saying what percent. I don't know the answer to this question, so it's x over 100, and it says the length of the south side of the park is. Okay, well, the south side of the park is the 40, okay? What percent of the length of the north side? Well, the north side's the 28, so I'm going to say of 28, right? And if you do this multiplication, you'll get the same answer, right? Which is the 142%, right? So which either a proportion, or if you're comfortable just doing the is over of, whichever way you do it, division or is over of, you will get the same answer. Okay, so that is problem number 34. It should be a quick one, however you do it. Okay, so let's move on to 35. So 35, new picture, also going to be used for 3 problems, right? So the Smith family is planning to build a 3-room cabin, which consists of 2 bedrooms and 1 living room. Shown below is the rectangular floor plan. So this is looking from the above the shape above the room, looking down. Okay, and the side view. So this is outside of the house, looking at the side. Okay, and it's telling us that the side view forms an isosceles triangle ABC. So that's this roof area here. The walls are perpendicular to the floor, so that just means that I have little right angles here. So perpendicular just means lines are at right angles. Okay, and then it says AC, which is this top line, is parallel to ED. So this is just some notation here. So these top and bottom lines are parallel. F is the midpoint of AC, so that is the middle point. And BF, okay, let's find BF, right? BF right here is perpendicular to AC, right? So a lot of information there. And then at the bottom, there's actually a little bit more. During the week, the Smiths plan to roof the cabin, and there's a 20% chance of rain. So a lot of information. We're probably not going to use it all for each of the questions, but we may use little parts of it for, remember, there's 3 questions here. So let's start off with the first one. It says, Mr. Smith plans to build a 3-foot wide walkway around the outside of the cabin as shown in the floor plan. So that's this left-hand picture. What will the area in square feet of the top surface of the walkway? So essentially, the shaded region here around the outside, that is the walkway itself. And if they're trying to figure out how much concrete they're going to need or how much brick they're going to need, right, they would need to know that. So essentially what we're going to do, I'm going to kind of simplify this picture, and we're going to say we have this rectangle, right, which represents the walkway, and then inside of that we have the house, right? And they're giving us dimensions for both of these. They're telling us that the inside one at the top is 24. Okay, and then I have a 30, right? Again, it's kind of on the outside edge, but it stops at these kind of inside top and bottom, right? So that's 24 by 30, and then the outside is 36 on the left, okay, and it looks like 30 on the bottom. So this is 36, okay, and this one's 30, right? So what we're basically going to do to figure out what the area of this shaded space is, kind of the whole outside, right, is to figure out the area of this entire big rectangle, and then subtract out the area that the house represents, and whatever's left over, that's the shaded region. So again, this is kind of some calculator work here, right? So let's start off with 36 times 30. So again, if you need to look at your reference sheet, rectangle area is just length times width. So 36 times 30, that represents the area of the entire property, okay, with the walkway in it. Okay, and from that, I'm going to subtract 24. Oh, 30, yeah, 24 times 30. Okay, so just be careful that your dimensions are correct. I was just double checking. Okay, so that leaves 360 square feet. So if we remove from that entire big space the house area itself, we're left with 360 square feet. Okay, I'm going to just double check. What is the area in square feet? All of these dimensions are in feet. Okay, so I don't have to do any conversions. There's my answer. Okay. All right, problem number 36. Okay, Mrs. Smith will install a ceiling fan in each room of the cabin and will place curtains over the 4 windows. Each of the ceiling fans has a price of $52. Okay, the price of the curtains for the small windows is $39.50, and the price of the curtains for the large window is twice that of the small window. Based on all this information, which of the following values is closest to the total price Mrs. Smith will pay? Okay, so I'm just going to do a little inventory here. I see that it says over on the left-hand side, this is a 3-room house. So if we have to do ceiling fans, I'm going to do 3 fans times $52 each fan. Okay, and then I have $39.50. Right, that represents the cost of the small windows. Right, and if I'm looking at my picture here, I can see that there's a small window here in the living room. There's a small room, one in the bedroom, and a small one in the other bedroom. So that is 3 smalls. Okay, and then I have 1 large in the living room as well. Right, so and that one is twice the cost of the small window. Right, so I could go to my calculator and say, what is 39.50 times 2, and that's easy enough. Right, so let's go do that, and we're just going to say 39.50 times 2. Okay. Times 2. So the big one, the big windows curtains, is $79 instead. So I'm going to say I have 1 large times 72. And the only thing I have left to do is to kind of throw all this into the calculator, right? I'm sorry, 79, not 72. 79. Okay. So now I'm going to throw all this in the calculator. If I take that 79, okay, and okay, add to that, okay, 39.50. Oh, try that again. 79 plus 39.50 times 3 plus 52 times 3. Okay, it looks like $353.50 will be my total. Okay, and I can take a look up here. I do have a $354, right, which is choice letter J. Okay. Last problem. Okay, Mr. and Mrs. Smith plan to roof the cabin on 2 consecutive days. Assuming the probability is independent of the day, what is the probability that it will rain both days? Okay, so this is a probability problem. They do tell us that the probability of rain each day is 20%. So I'm going to write that out. 20% is 20 over 100. And if I simplify this, I can just kind of chop off the zeros, and that's 2/10. 2/10 simplified is 1/5. Okay. So I could do that, or I could just call this, if I could do 20 divided by 100 and get 0.1/5, 0.04, what am I doing? 0.2, okay? Right, however you want to do it, either of these numbers, right? The way that you're going to do probability is you're going to say, okay, let's say if these 2 days are like Monday and Tuesday, are the 2 days, we're going to write the probability that it rains in each of those. So I'm going to use my 1/5 here, right? 1/5. Okay. And the probability on Tuesday, because it says that they're independent, okay, what that means is the fact that it was 1/5 on Monday makes no difference on Tuesday, so it's going to stay 1/5, right? Nothing's going to change. The way that we calculate multiple events happening is just to multiply these 1/5s together, right? So I'm going to go to my calculator to get the calculation itself, right? And I'm going to say 1/5, okay, 1 divided by 5, okay, equals times 1 divided by 5, okay? Oop. Let's try that again. I did 1 divided by 5, okay, times another 1 divided by 5, right? Which, again, you can use the 0.2s if you're more comfortable with that. It's 0.04. But the big idea here is that if I'm going to calculate independent probabilities, I'm just going to say what's the probability it happens on the first day times the probability it happens on the second day. They are both 20%, so I'm going to go with my final answer of 0.04, 1/5 times 1/5, okay? All right. Problem number 38. We have 38, 39, and 40. Okay. So problem 38 says, which of the following expressions, okay, when evaluated, equals an irrational number? Okay, so here's our kind of vocabulary. Uh, Irrational means that it is something that cannot be written as a nice fraction or decimal. Okay, another way of thinking about it is the definition of irrational is a number that does not repeat, and it also does not end, right? So if I looked at the calculator, it would be a random jumble of decimal numbers that kind of goes all the way to the end, and we assume that it's not going to end, right? So the easy thing to do here would be to, again, let's go back to our calculator and use it. We're allowed to use it for all 60 questions, right? We can go back to our calculator, and I can just start typing these in, right? I could say, what is the square root of 2? So second squared, square root of 2, right? Oh, hit my right arrow to get out of the square root, divided by, and I can do it again, the square root of 8, and hit enter. Hey, there's a nice decimal, right? So that's not irrational. Irrational means that I can't write it as a nice terminating decimal or a fraction. So this one is not irrational. Same thing with 8 over 2. I could type those in. In this case, you would get the square root of 4, which is 2. That's out, right? And so I can kind of go through each of these and do that. One thing that might help you, though, is to know your radical rules, right? So here's why I say that. Instead of me going to my calculator and having to spend all that time typing it in, here's what I know about my radical rules, right? So let me bring up the problem again, okay? So I'm going to say the square root of 8 over the square root of 2 is the same thing as the square root of 2 over 8, right? If I can put them back into the same radical, and that's really the square root of 1/4. Right? The square root of 1/4 is the same as the square root of 1 over the square root of 4. The square root of 1 over the square root of 4 is just 1 over 2, right? So I didn't have to use my calculator, and I was able to quickly get that 1/2. Same thing's going to happen with the top. If I say this is the square root of 8 over 2, well, that's the same thing as the square root of 4 over 1, which is just 2. Done, right? Square rooting and squared, this is a property. They just cancel. This one's 8. Okay, so if you notice, I'm getting these nice fractions and whole numbers. That means that none of these are irrational. Okay. Problem number, letter J, if I do the square root of 8 times the square root of 16, that is the same as just multiplying them under the same radical, 2 times 8, okay, which is the square root of 16, okay, and that's going to just be 4. Again, nice whole number, right? That's bad, okay? The square root of 2 plus the square root of 8, we cannot add these together. I'm going to do something that you should not do. It is not the square root of 10. Right? So don't do that. You can't just add what's under the radical. This does not work. Okay? We actually can't combine these in their current state, but here's all I care about. I eliminated every other choice. It's got to be k. Okay? And if you have some extra time and you want to verify, again, you can go back to your calculator and just verify, okay, that the square root of 2, okay, plus the square root of 8, okay, let's just see that messy number. If you notice, this is the one that's giving me a decimal. There's no pattern. There's no end in sight. That's the irrational number. Okay. So however you're doing it, I think this is probably your quickest strategy, but that's the idea. Okay. All right. Problem number 39. This is another geometry problem. Okay. A line through the origin, which is 0, 0. That's right here. Okay. So I'm just going to note that that's 0, 0. Okay. And the point 10, 4, that's already noted on our graph, is shown in the standard xy coordinate plane. The acute angle between the line, that's this thing, and the positive x-axis, that's this thing, has a measure of, this is theta, right? So call it whatever you want, okay? What is the measure of tan theta, right? So this is actually a trigonometry problem. So here's what I'm going to remind you about. You had probably something that you may have seen in all of your classes called SOHCAHTOA, right? Where sine is opposite over hypotenuse. So if I want to write this out, the sine of theta is equal to opposite over hypotenuse. Okay. The cosine of theta is equal to adjacent over hypotenuse. And the tangent, which is the one we care about, of theta is equal to opposite over adjacent. Okay. So if they're saying what is the value of tan theta, what I'm going to do is I'm going to say, well, what is opposite from theta over adjacent to theta, right? I'm going to set up that fraction, and if you notice, all my answers over here are fractions, right? So if I take a look at this, I'm going to kind of say, let's make a triangle, and I'm going to do that by just taking this point up here, drawing a straight line down at a right angle, and if you notice, I make this nice triangle. And so we need to figure out what any of these sides are, what the lengths of them are, okay? Diagonal lines like this, ones that are not horizontal and vertical, they're not easy to calculate. You have to do like a distance formula or something like that, right? But this one right here, I can say 0 up to this point here, which is at x equals 10, has to be 10 units. And then the same thing's going to happen if I am at a y value of 0 here and I go up to 4, that means this one's 4. Okay? Here's theta in the corner here, right? So I'm going to actually say opposite from theta, okay, this is opposite, okay, adjacent to theta, okay, and then this unknown side, the one I never figured out, is the hypotenuse. But guess what? I don't care about the hypotenuse, right? This particular ratio, tangent, is opposite over adjacent. Well, in this case, for us, opposite is 4, adjacent is 10. That's 4/10, and I can more easily write 4/10 if I reduce it as 2/5. Okay, so this one is you remembering your sine, cosine, and tangent, and also realizing that you can draw a horizontal and vertical line to make your own right triangle. So we can get choice letter D. Okay, all right, last problem for part 4. Okay, so this one is an absolute value equation, has 2 solutions. Okay, those solutions are equal to which of the following pairs of equations? So here's the first thing I'm going to note for you. All of these, right? First thing, okay, so here's the first thing I'm going to note. This 2x minus 5 is assuming that you're going to think that you can put these together. Okay, if something's inside of a square root or an absolute value or something square, if it's in some kind of grouping symbol, you cannot combine something on the outside with it, right? So I can kind of look at this one and say, you know what, all the rest of them have 8s. This one has 5. It looks like they're trying to distract me. I'm going to get rid of that one. That's not right, okay? I'm also seeing that the rest of them have the 2x minus 8 as the only thing on the left-hand side. So maybe it would be helpful instead, right, if I kind of bring this problem down, to move the 3 over to the other side, right? So if I subtract this 3 on both sides, here's what I'm left with. The absolute value of 2x minus 8 is equal to 2, 5 minus 3, right? So again, that kind of points me to, okay, well, this one's got some 8s in it. That doesn't make a whole lot of sense. They were probably thinking I might make the mistake of adding together these numbers instead of subtracting them. Let's get rid of that, right? And so now I just have to figure out which of these kind of makes the most sense, okay? So here's the idea with absolute value, okay? Absolute value, if I plugged in this case, a -2 into an absolute value, I would get an outcome of 2. I could also plug in a +2, and that would give me the same answer, right? So if I'm trying to get an answer of 2, I could have the positive version or the negative version on the left-hand side. So that's why a lot of these problems, you can see they're kind of saying, well, 2x minus 8 is what's in my absolute value. So I could have the positive version of that, right? That kind of looks like this one, right? Or I could have the negative version, okay? So if I'm looking at this one, I'm kind of saying, oh, J is kind of a weird 2 and 8 kind of thing. But if I look at G and K, they're almost identical. The only difference is that K has the parentheses around 2x minus 8, and G does not, okay? In this case, the one that we want is letter K, okay? The positive version of 2x minus 8 is just it by itself. The negative version is the entire expression being made negative, right? So I have to put the negative around the entire expression, not just the 2x. And so that's why we're going to go with K instead of choice G. Okay, so again, that's the end of part number 4. It was a longer one because we had some multi-part problems. Okay, again, this was a part of a playlist, so we will continue in part 5 with numbers 41 through 50, and then we'll wrap it up with part 6, okay, which will cover everything up through number 60. Okay, again, if you have any questions about anything specific, please leave them in the comments, and I will answer them. I'm always monitoring my comments for my videos. Okay, if you could like and subscribe, that would help immensely in getting the word out about these practice videos, and so hopefully they will help you and help others. So please like and subscribe, and I will see you in part 5.